Okay. It's Saturday school. Here we go. Welcome, everybody. I'm Lars Bildsten, the director here at the KITP, and it's really my pleasure to see you all here on this bright, rainy, sunny Saturday morning in Santa Barbara. I always like to ask one question before we start any event, which is, for how many of you is this your first time at the KITP? Raise your hand high. Okay, so now when we get to the town hall discussion, I'm going to go around and ask each of you how you found out about the event, because I'd say one challenge we're having is getting the word out, because we've got more capacity. You can see there's empty seats here, and I'd rather have a full house than a half full house. We're at 2/3 probably. Some are still sleeping in, I think. But it is really important to us because this is something we continue to do once a year. And so I want to talk briefly about the KITP, a little bit about this, and then hand it off to Duncan Brown to get things going. So the KITP has been on the UCSB campus since 1979. We run long scientific programs, typically 2 to 3 months, more often 3 months, where 25 scientists are here on a given day to collaborate and do research with all of their scientific peers. That leads to about 800 visitors per year coming through the Institute who are here for a month or longer. And so it's a very international crowd. Half of our visitors are from outside the U.S., and that remains true even today. That's all I'll say. And our primary funder is the National Science Foundation. Our next funder is UC Santa Barbara, and then the Gordon and Betty Moore Foundation, and of course the Kavli Foundation. We've had a recent large donation now 2 years ago from Charlie Munger of $65 million that allowed us to build a big residence to house our visitors. So none of you are seeing that. Maybe next time we can arrange a field trip. But many of the visitors now stay in a large facility that allows them to keep interacting all night and through the weekends, I hope. I know there was a barbecue last night. I was a little bit exhausted, so I didn't go. I'm looking at it was good. Okay. And so this year is our renewal year, so wish us luck. In May, we're at the NSF to make the case for continued renewal of the Institute. We're optimistic. The budget, of course, is the only real question. So with no further ado, what I'd like to do is just briefly say that we do tie these always to a conference. And these one-week conferences we have at the Institute are tied to these large programs. So we have a large program on massive stars. Massive stars, that program had already been arranged and on the books before the LIGO discovery had happened. It ends up that LIGO discovered massive stars in their black hole form. So, of course, we were able to bring some of that science into this program. But most importantly, it was pretty clear to us here at the Institute that the teachers' conference we should do this year should be on the LIGO discoveries. And therefore, we were able to keep some of the speakers that we had here this last week, which is ending yesterday, on a Massive Stars conference to do this one-day event for us. So I think we really do want to encourage, I think given the number of people, I know Lisa is really good at taking questions during her talk, because we saw it yesterday. So be ready, Lisa. You may get more today. Okay, Duncan, please.
Thank you, Lars. So I'm Duncan Brown from Syracuse University. I'm a member of the LIGO Scientific Collaboration, which is an international collaboration of over 1,000 scientists from all over the world who've been working for many years to build detectors and eventually last year discover gravitational waves from emerging black holes. So this has been a huge international effort that the US taxpayer has funded for many years to really push the frontiers of scientific discovery. We have a great selection of speakers today who are going to talk about the various different aspects of the gravitational wave discovery. We're going to have people talk about the detectors, the hardware themselves, these machines that try and measure these ripples in space-time that are caused by the emerging black holes as they pass through the Earth. We're going to have people talk about the astrophysics, the gravitational wave sources. Lynn Kaminsky, who'll be coming in a bit later today because she had the usual San Francisco, Santa Barbara plane troubles. Lynn will be here at lunchtime, and she will talk about teaching general relativity, gravitational waves in the classroom. And then Terry will talk in the afternoon about some of the core collapse supernova sources, so sources of gravitational waves beyond just black holes. So let me introduce Lisa Barsotti. Lisa is a scientist at the Massachusetts Institute of Technology. The LIGO laboratory The organization that's funded by the National Science Foundation is a joint project between Caltech and MIT. LIGO builds and operates two LIGO detectors, two gravitational wave detectors, in collaboration with our partners Virgo in Italy, so we actually have an international network of detectors. Lisa is a member of the LIGO lab. She started her work over in Italy with the Virgo Italian gravitational wave project and moved over here. And Lisa is one of the real-world experts on building these gravitational wave detectors, on understanding how they work, on making the current generation detectors work, and then planning out for the future generation of detectors as we make them more sensitive and we can reach further out of the universe. So thank you, Lisa.
Thank you.